ever think about those flying cars we were promised? Where are they? Sci-fi movies, Back to the Future, all that.
Yeah, it's funny how those predictions pan out, right? Like, we're all supposed to be zipping around in our own personal spaceships by now.
Right. And this week's stuff you guys sent in, it really got me thinking about that. We've got articles on Mars, black holes, even a whole thing about what astronauts might be eating up there. Mouse stew.
Mouse stew, huh?
Apparently, it makes you realize, how these big ideas, these futuristic dreams often come with these kind of quirky, unexpected twists when you look at the details.
Absolutely. Going through this material, I was struck by that too. It's like every giant leap forward seems to have this side of, well, kind of the absurd.
So should we dive right into the cosmos then? Mars, it's still got that hold on us, right? But it's also kind of weird. We went to the moon, what, like half a century ago, and Mars just keeps getting pushed back.
I think part of it is the sheer scale of the challenge, right? We're talking
Oh
about
yeah.
a whole different level of commitment compared to the moon missions.
It's like we sprinted to first base and then just decided to chill there for a while. We've got people in the ISS, but as some of the articles pointed out, that's like a tiny hop compared to getting to Mars.
Yeah, and those astronauts on the ISS are actually providing valuable data on the long-term effects of living in space, you
Hmm.
know? Like the isolation, the confined spaces, the radiation. They're kind of like the test pilots for a Mars mission in a way.
Right. And then you've got Buzz Aldrin, a guy who actually walked on the moon, saying we could have a Mars colony in a few decades, starting with robots on Phobos. That's ambitious, to say the least. One article called it borderline insane, comparing it to the moon landing itself.
And that's kind of the point, isn't it? Those seemingly crazy goals, they force us to innovate. You can't just, whoosh your way to Mars. You've got to come up with new technologies, new ways of thinking. Like, remember when SpaceX said they'd reuse rockets? It seemed impossible back then.
That's like no big deal. So, okay, we're on Mars. What are we eating? Mouse stew.
Well, according to a space nutrition conference from, get this, 1964, that might not be too far off.
1964. Seriously. Mouse stew. I mean, I complain about getting the wrong order from Uber Eats.
It's all about efficiency, I guess. You can't exactly bring a herd of cows on a spaceship. Smaller animals, they reproduce faster, take up less space. Makes you wonder what other culinary surprises are in store for future space travelers.
I'll stick with my veggie burger for now, thanks. But hey, at least there's the Martian Sunrise cocktail. Neil deGrasse Tyson came up with it. Rum, cranberry juice, orange juice, lemon slice. Not sure how well it goes with mouse stew, though.
Probably not the best pairing.
Ah,
But it's a fun thought, right? And it brings up this whole thing about how basic things like cooking become totally different depending on where you are in space.
yeah, like Venus. You could literally bake a pizza in like 9 seconds just from the
Almost
heat.
like seconds. That's
Yeah.
faster than my toaster oven.
And then you've got the opposite problem, like coffee in space taking forever to freeze, even in a sealed container. The physics of it all, it's wild. And speaking of wild physics, how about black holes and wormholes? Just thinking about spaghettification makes you think twice about interstellar travel.
Yeah, not the most pleasant way to go, being stretched into a thin strand of atoms. Though, fun fact, the bigger the black hole, the less intense the spaghettification at the event horizon. Still wouldn't want to test it out, though.
Right. And wormholes. Theoretical shortcuts through space-time, but the
Yeah.
energy needed to open one, it's insane. Like trillions of trillions of trillions of watts. We can barely keep our laptops charged.
Exactly. And then there's the density of things out there. Like neutron stars, a spoonful would weigh billions of tons.
It's spoonful. Imagine trying to stir your coffee with that. It's mind-boggling. And then you get to the event horizon of a black hole, the point of no return. What happens beyond that? No one knows. It's like physics just shrugs.
That's what's so captivating about space, though, right? Those
Yeah.
unknowns, the sheer mystery of it all.
It keeps you on your toes. And speaking of things that mess with your mind, how about time? Einstein's relativity, time dilation, it's crazy.
It is. And it has these real implications. Like, If you travel near the speed of light, time slows down for you compared to people on Earth. So you can go on this epic space voyage and only age a few years, but back on Earth, centuries could have passed.
Imagine coming back to Earth after that. Everyone you know is long gone. It's a whole different world. But it makes you think, who should be doing this exploring? Humans or robots? We've got this ongoing debate, right?
Definitely. Stephen Squires, the planetary scientist, he argues that humans are essential, that we have this ability to adapt, to improvise, to synthesize information in a way that robots just can't.
It's true. Robots are great for data collection and all that, but they're not going to be making those split-second decisions when something unexpected happens.
Exactly. And there's the inspiration factor, too. As Squires put it, no one's ever going to give a robot a ticker tape parade.
So true. Humans in space, it just captures the imagination in a way that robots never could. But let's talk about the risks, right? Space is a dangerous place. Though one thing that surprised me was this whole thing about RTGs, those nuclear-powered generators on some of our space probes.
I think there's a lot of misconception about that. They're incredibly well designed, multiple layers of protection. And the idea of us, chucking nukes into space for science is just not true.
Okay, good to know. Now, the big question, the one we all want answered. Are we alone? The search for alien life, there are so many ways to go about it. We could be searching for microbes on Mars or looking for signs of life in the atmospheres of distant exoplanets.
Neil deGrasse Tyson seems to think we'll find something on Mars first, maybe even evidence of past life, but it's a tough call.
And then you've got places like Europa with this whole ocean under the ice. Imagine the life that could be down there.
It's a fascinating thought, but getting to it, drilling through miles of ice, the technology needed for that is, well, we're not quite there yet.
But it's something to shoot for, right? And while we're talking about definitions, what about the whole what is a planet debate? Pluto got demoted, and now you've got these other objects that are kind of, sort of planets.
It's all about those fine lines. Pluto didn't quite meet the criteria, and then you have these exoplanets, some even smaller than Mercury. It shows how science is always evolving, even the basic categories we use.
Makes you think, what other scientific truths might change as we learn more? And speaking of planets, remember that story about Neil deGrasse Tyson wanting a rubber Saturn as a kid because it's so light it could float?
Yeah, it's a great story, isn't it? And it captures that childlike sense of wonder that so many scientists have. I remember trying to build a robot out of Legos when I was little. Didn't exactly work, but the fascination was there.
It's that spark of curiosity, right? Now let's talk asteroids. Asteroid mining, what happens if we suddenly have a ton of platinum? Doesn't that just crash the market?
It's a legitimate question. Basic economics would suggest that a flood of resources like platinum would lower the price. But then again, a lower price could lead to new applications, new industries we haven't even thought of yet.
So it's a gamble, a potential economic earthquake. But let's shift back to Earth for a moment. There's this something about the view of Earth from space that just hits you differently.
I think it's that perspective, seeing our planet as this fragile, interconnected whole floating in the vastness of space. There's the reason astronauts use words like spiritual and awe-inspiring. Mike Massimino even said the view was more beautiful than heaven.
It's enough to make you want to take better care of our little blue dot, that's for sure. And remember Carolyn Porco's The Day the Earth Smiled project, taking a new picture of Earth from Saturn. It really highlighted our shared existence, our place in the cosmos.
It's those moments that remind us of the bigger picture. Now, on a slightly more grounded note, how about those tides? There's this idea that the full moon alone causes the highest tides, which isn't quite accurate.
It's actually a combination of the moon and the sun's gravity working together, like a cosmic tug of war. Neil deGrasse Tyson puts it nicely. He says, blame the sun, too.
And those supermoons we hear about, they sound impressive, but the difference in size is pretty small. As Neil said, it's like comparing a 16-inch pizza to a 15-inch one. Not exactly a dramatic difference.
Maybe we should call them slightly bigger moons instead. But speaking of our celestial neighbors, Venus and Mars are like cautionary tales when it comes to climate change, aren't they?
They really are. Venus, with its runaway greenhouse effect, is a scary example of what can happen when things go too far. And Mars, on the other hand, seems to have had a greenhouse effect that just fizzled out, leaving it a cold, dry desert.
So they're like natural experiments, showing us the different paths climate change can take. Makes you appreciate our own planet's delicate balance. And let's not forget our own natural shield, our magnetic field.
That magnetic field protects us from the constant bombardment of charged particles from the sun. And when those particles do hit our atmosphere near the poles, we get the aurora borealis, the northern lights.
The northern lights is like nature's own light show. And speaking of looking up at the sky, telescopes, they've completely changed our understanding of the universe.
Every new generation of telescopes is like opening a new window onto the cosmos. Neil deGrasse Tyson calls them ego-dismantling devices because they force us to confront just how vast and ancient the universe truly is.
I kind of like that term, ego-dismantling devices. It's a good reminder to stay humble. Now let's dive into something that's all around us, water. A lot of it may have come from comets. Can you believe it?
It's true, a significant portion of Earth's water may have been delivered by those icy visitors from the outer solar system. And as Neil points out, not all water is created equal. The water found on different planets and moons can have very different origins and compositions.
Speaking of comets, remember reading about that one? The size of the dinosaur killer that could potentially flood Florida if it hit? Talk about an unwelcome delivery.
Yikes. And we tend to think of water as simple, but even its different states, ice, liquid, steam, there's some really complex physics going on there, like the slipperiness of ice. It's not because your ice skates are melting it. It's an inherent property of the ice itself.
So many things we take for granted, you know? Like, why is the ocean salty? I remember asking my dad that, and he told me it was because of all the shipwrecks. Yeah.
Sadly, no pirates involved. The salt actually comes from rocks. Rainwater erodes the rocks, dissolves minerals and salts, and the rivers carry them into the ocean. It's a slow process, but over millions of years, it adds up.
Speaking of water, it's easy to forget how precious it is. I read about the challenges New York City is facing with its aging water system. And then you've got people in parts of Africa walking miles just to get clean water.
It's a stark reminder of the inequalities we face globally. And then you think about the impact of bottled water, all that plastic waste.
Yeah.
Makes you think twice about just grabbing a bottle from the fridge.
Definitely. So let's shift gears a bit and talk about something that's been on everyone's mind, climate change. It feels like we're seeing more and more of these intense storms, you know?
And the science backs that up. Neil deGrasse Tyson asked this great question: where the hell do these storms come from? It all boils down to the interaction of warm and cold air, the evaporation of water, creating this unstable atmosphere. The warmer the planet gets, the more fuel for these storms.
And we're already seeing the consequences. Fish swimming in the streets of Miami during high tides, the flooding from Superstorm Sandy. It's scary stuff.
Cynthia Rosenzweig, the climatologist, she compares the impact of greenhouse gases to wrapping the Earth in a thicker, fluffier blanket. It traps more heat, disrupts the whole climate system.
It's like we're messing with the planet's thermostat without knowing how to fix it. Sir David Attenborough's message about not wasting Earth's bounty really hits home, you know? And this whole idea of geoengineering, trying to fix the climate with massive interventions, it's risky.
Exactly. David Grinspoon, he talks about the danger of trying to manipulate a system as complex as our planet's climate. What if it backfires? What if we can't reverse it?
It's a big gamble. Bill Nye talks about this close call we have between the urgency of climate change and the lack of scientific literacy. It feels like we're running out of time to act.
It's a race, that's for sure. And we need to be smart about it. Neil deGrasse Tyson talks about how Maybe the focus shouldn't be on demonizing energy consumption, but on how we produce and use it.
It's not about going back to the Stone Age, it's about finding sustainable solutions. And who knows what challenges lie ahead. Neil also said that the biggest threats to humanity in the future might be things we haven't even thought of yet.
That's a sobering thought, right? It underscores the need to stay curious, to keep adapting. Like the idea of using a kinetic impactor to nudge a dangerous asteroid away from Earth.
Pretty cool idea, using a giant space hammer to save the planet.
Hmm.
But let's shift gears now and talk about something that explains a lot about us humans. Evolution. We're not better than monkeys, just
Different.
variety.
Exactly. Richard Dawkins, he describes evolution as the laws of physics working to create life. Monkeys evolved to live in trees. We evolved to do,
I know.
well, whatever it is we do.
And it wasn't a straight line either. We split off from orangutans, gorillas, chimps, a whole family tree. And we even shared the planet with Neanderthals for a while. Guess who came out on top?
The Neanderthals, fascinating group, but for whatever reason, they didn't make it. And the whole intelligent design versus evolution debate, it highlights just how different our worldviews can be. But the scientific evidence for evolution is overwhelming. Bill Nye says it best. You only have to be good enough to survive.
Good enough. I like that. And it's not just humans who have these complex societies. Ants have wars. Bonobos have, well, let's just say they're very social. It makes you realize how much of our behavior is rooted in our animal nature.
It's fascinating, isn't it? And speaking of fascinating behavior, how about human sexuality? Dr. Carolyn Porco had that great line about not wanting high-maintenance items like husbands.
She's got a point. And Mary Roach's research suggesting that long-term and same-sex couples might have better sex because they're more present, more in tune with each other's needs, it makes you think.
It's a reminder that intimacy is about more than just the physical, right?
Oh.
And then there's Neil deGrasse Tyson's astrospermicist observation about sperm speed.
Ugh.
Only he could connect that to astronomy.
That's Neil for you, always finding a cosmic angle. And who knew we had erectile tissue in our noses? The nose boner, Mary Roach called it. Never thought I'd learn about that on a space podcast.
It's amazing what you learn, right? And Dr. Ruth Westheimer, her message about women taking responsibility for their own sexual satisfaction is so important.
It's about empowerment, knowing what you want, and not being afraid to ask for it. And our understanding of gender and sexuality is constantly evolving too. Dr. Rebecca Oppenheimer, as a transgender woman, brings a vital perspective to these discussions.
It's a reminder that we're all constantly learning and growing. And as Malcolm Gladwell says, biases are learned, not inherent. So we can unlearn them too.
It's all about challenging those assumptions, opening our minds. Now let's talk about something everyone loves: food. Anthony Bourdain, he had such a unique view on what we consider weird foods.
He really did. Like his example of bitterness being a prized flavor in Filipino cuisine. It's all about cultural context, what we're exposed to, and this nutrition transition as societies become more industrialized, their diets change too, often for the worse.
It's interesting how our tastes adapt, right? Dr. Marian Nessel, she points out that our bodies are better at making us want to eat than to stop eating.
Makes sense. Our ancestors needed to eat whenever they could. And Bourdain talked about how vegans in some cultures might actually eat more insects than they realize, just from what's in their rice. Makes you wonder what's really in your food sometimes.
Right. And the thrill-seeking aspect of food, like eating fugu, the poisonous blowfish, it's crazy. And Bourdain himself, drinking cobra blood, that's hardcore. But let's get a little more philosophical now. Creativity, consciousness. What is it that makes us want to explore, to create, to understand?
It's a fundamental question, right? Einstein said the impulse to wonder is at the heart of art and science. And you've got those quotes about doing things because they're hard, pushing ourselves beyond our limits. What drives that?
I think it's wired into us, that need to challenge ourselves, to figure things out. Dr. Heather Berlin, she defines consciousness as this first-person subjective experience, that awareness of ourselves and the world around us, but it's different from self-awareness, knowing that you are a separate being.
It's mind-boggling. And art, that creative impulse, where does it come from? Peter Max, he talks about art living in between the peacefulness and the universe, which is a beautiful way to put it. And the debate about whether computers can truly create art, can an algorithm really replicate human emotion?
It's a tough one to answer. And Kant, he talks about art bridging the gap between the mundane and the sublime. It elevates us, takes us out of the everyday. Now, video games, they've been around for a long time, but there's still this debate about their impact, especially violence in games.
Yeah, the science is still out on that one. But there's no denying that games can teach us things, build skills. Even Christopher Emdin compared complex rap lyrics to the logical processes of scientific thinking.
It's about engaging with complex systems, even if it's just for fun. Speaking of things that can be good or bad, how about drugs?
It all depends on the context, right? Like Cara Santeria said, a drug itself isn't inherently good or bad, it's how we use it. There's so much potential for therapy, like MDMA for PTSD or ketamine for depression.
It's about responsible use, understanding the risks and benefits. Now, how about a little fun with physics? Roller coasters, they're basically physics lessons disguised as amusement park rides.
Exactly. Potential energy converting to kinetic energy, centripetal force keeping you in your seat during those loops, it's all there. And even the shapes of the loops are mathematically optimized for a smooth ride.
Who knew there was so much science behind a good scream? Now let's warp over to the world of Star Trek. George Takei talks about the Enterprise as a metaphor for Starship Earth. The strength and diversity, it's a timeless message.
Star Trek, it was way ahead of its time in terms of social commentary. And Neil deGrasse Tyson, he points to shows like that and The Twilight Zone as examples of science fiction tackling real-world issues. But let's be real, those transporters, pure science fiction.
Yeah, teleporting people, not going to happen anytime soon. But Carolyn Porco, she actually helped design the scene where the Enterprise rises from Titan in the 2009 movie.
That's pretty cool. It's that intersection of science and art. Now, how about mind uploading? Transferring our consciousness to a computer. Digital immortality. Scary or exciting?
It's tempting, right? But the human brain is so complex, those trillions of connections. Can we really capture all of that in a machine? Neil deGrasse Tyson jokes that he'd rather go for a brain transplant than a brain backup.
Probably the safer option.
Oh, my.
And remember, we started by talking about flying cars. And Elon Musk, he's got this alternative, tunnels.
Tunnels, huh? Not as glamorous as flying cars, but maybe more practical. And it highlights the challenges of actually making flying cars safe and reliable. Speaking of making things fun, combining science and comedy, Seth MacFarlane, he's a master of that.
Humor is a great tool,
Yeah.
right? It makes science more accessible, more relatable. And speaking of science in movies, The Martian, they actually got the rotating spaceship creating artificial gravity pretty accurate.
Points for scientific accuracy. Though Neil deGrasse Tyson has had a field day with some of the less accurate sci-fi out there, like the sound in space and Star Wars. But let's talk about the human mind for a moment. We're wired to believe, to see patterns, even when they might not be there.
It's how our brains are designed to find meaning, to connect cause and effect, and that can be exploited, like in magic shows, or by people claiming psychic abilities. Neil deGrasse Tyson, he's a healthy skeptic, always questioning things.
It's good to be skeptical, right? Not everything is what it seems. Eyewitness accounts, they're notoriously unreliable too, like Chuck Nice says. Our memories, they're not perfect recordings.
And conspiracy theories, they can be really damaging because they undermine trust and science and institutions. It's important to be critical of information, to look for evidence.
Truth matters. Now, what about the search for extraterrestrial intelligence, SETI? People have been reporting alien encounters for decades, but we still haven't found that smoking gun.
Dr. Seth Shostak, he's heard it all, people claiming they've met aliens. But the scientific approach is about looking for signals, for evidence. And Alan Alda and John Hodgman have these funny theories about why aliens might avoid us altogether.
Like, Earth is just too weird for them. But Stephen Hawking warned about the potential dangers of contact, right? What if a more advanced civilization finds us? Edward Snowden even suggested we should encrypt our messages, just in case.
Makes you think, what would first contact really be like? We're actively searching with projects like Breakthrough Listen, but it's like finding a needle in a cosmic haystack. And then you have the wow signal, still unexplained after all these years.
Chilling, isn't it? And finally, let's touch on time travel. Science fiction loves it, but is it really possible?
So far, no dice. Bill Nye, he calls himself the time dilation guy, acknowledging that the only time travel we know of is forward through things like relativity, but backward time travel, no evidence for that. And even cryogenics, freezing yourself to wake up in the future, that's more science fiction than science fact.
So, no time machines or trips to the past just yet. But that's what's so great about this whole exploration of science, right? It's a blend of facts, speculation, and that never-ending quest to understand the universe and our place in it.
Exactly. And that quest, with all its twists and turns, it never gets old.
So, while we might not have flying cars yet, the universe is full of wonders, far more mind-blowing than we could have ever imagined. What unfulfilled technological promise are you most curious about? And what unexpected scientific discovery might be just around the corner? Who knows what the future holds? Thanks for tuning in to The Deep Dive.